Plasma arc machining parameters. The parameters that govern the performance of plasma arc machining can be divided into three categories: those associated with the design and operation of the torch, those associated with the physical configuration of the setup, environment in which the work is performed. The torch. The modified stabilized arcs came to be known as plasma torches or plasma jet because the plasma of the arc column is pushed out of the nozzle in the form of a high velocity jet. An additional feature of the plasma torches is that the anode tube is in the form of a constricting nozzle so that further confinement and acceleration of the arc takes place in addition to the constriction due to the stabilizing flow. The plasma torch consists of a non-consumable cathode rod of 2% thoriated tungsten and a converging anode nozzle with a suitable orifice. The electrodes are separated by an insulator of high carbonate resin or some suitable rubber. Usually for vortex stabilized torches, the gas is fed tangentially through an inlet in the insulator. For shield stabilization of the gas is fed through small ports around the cathode. Both the electrodes are water cooled. Modes of operation of DC plasma torches. Non-transferred arc mode. The DC power source is connected directly across the cathode and the nozzle is so that the cathode and nozzle carry some current. In such cases, the plasma is in the form of a flame useful for spraying, ceramic working, and chemical synthesis. The hottest portion does not appear outside the nozzle. The anode dissipation is lost in useless heating of the nozzle. Transferred arc mode. In this mode of operation, the cathode is connected directly to the negative of the DC source, while the anode nozzle is connected to the positive of the supply through a suitable resistor to limit the current through the nozzle to about 50 amps. The metal workpiece to be processed is then connected directly to the positive of the supply. When ignited, a pilot flame is established between the cathode and nozzle, which provides a conducting path for a high current constricted arc between the cathode and workpiece. Once this arc is struck, the pilot frame circuit is disconnected. This method is limited to cutting, welding, and hard surfacing of metals. The electrothermal efficiency of transferred arc mode is 20 to 30% more than non-transferred arc mode. Turbulent mode. When high velocity flames are required for material removal by melt blasting or spraying, high gas flow rates which give rise to turbulent jets are used. Those flames are short in length and are rather cold outside the nozzle. These are used for cutting, low quality welding, and spraying. Laminar flow. When low velocity or long flames are required, this mode of torch operation is used. Low gas flow rates are maintained in long nozzles to obtain a laminar flame. This is used wherever the processed material is not to be sputtered out or when the disintegration of molten drops into fine droplets is undesirable. Flames with velocities 50 meter per second and lengths up to 900 mm can be achieved.